Okay, hi everyone. My name is Don Otter and Jenny has just introduced me. I've been in academia and also mainly in industry for years and years. That 30 is now getting up to 40 and I'll be talking about that today. What I'll be talking about today is, I'll just get this out of the way. I've got a little screen there. I'll be talking about infant formula. And when I'm talking about infant formula, I'll be talking about the evolution of infant formula with emphasis on individual components. And you're all probably thinking, what is all that about? And I'm just about to tell you. Okay, so let's get going. Now, another title for this I thought could be quite useful is infant formula more than the sum of its parts. And what do I mean by that? You'll have to wait and we'll find out as I get going. Okay? Right. Whenever we talk about infant formula, every manufacturer puts out this notice, important notice, breast is best. And this is really just saying to mothers that if possible, breastfeeding is the best way that you can really give the best sustenance to your baby. And I'll be talking about that today as well. When I talk about infant formula, I talk about the infant formula that's made in Australia and New Zealand. And we have to understand that because we're dealing with babies, there's very strict regulations about the manufacture, the selling, and the marketing of infant formula. Right, let's start with a quiz. What do we know about infant formula? There'll be chocolate fish at the end of the seminar or webinar if you can answer all these questions. What is a wet nurse? What components in milk are we targeting in infant formula? How many types of infant formula are there available now out in the shelves? Can we use cell culture to make infant formula? And we'll talk about that. And what should we be going after? What do we mean by all that? Let's have a look. So, we're going to talk about the good old days, only briefly, because I could talk on infant formula probably for about at least 3 hours. And you'd probably get sick of listening to me by that. What's all the fuss about with infant formula and what's new and exciting? I've added a couple of, these are recent headlines that I have seen. Catastrophic and preventable. Mother sues Mead Johnson over baby's death. That was earlier this month. Voluntary code is not working. Exploitative marketing in baby formula infant milk industry. Salmonella lactalis, which is one of the biggest dairy companies in the world, has just been charged in France. That was a couple of days ago over infant formula recall. And this is a really interesting one that came out last week. Most health claims, this was done by a group in the UK, most health claims on infant formula or formula milk are not backed by evidence. And those claims include helps supports development of brain and or eyes and or nervous system, strengthens, supports a healthy immune system, helps, supports growth and development. So there's some big statements there that we have to think about. I've put a can of standard infant formula there. And what have we got there? We've got quite a big ingredient list, and we'll go through some of these later on. This is one for a sheep infant formula. You can see what we have to measure. There's a lot of vitamins, minerals, etc. There's some interesting ones there in prebiotics, which we'll talk about as well. And all these add up to what infant formula is. What are we trying to do with infant formula? And I first started in infant formula back in 1982 or 3, so it's almost 40 years now. And the holy grail then was to mimic human milk. Simple as that. 40 years later, what are we trying to do with our infant formula? We're trying to mimic human milk, human breast milk, okay? Here, I've just got some comparisons, and we'll talk about these in more detail later. When you look at lactose, fat, protein, and oligosaccharides, on the left there in that circle, you've got colostrum. On the right, you've got breast milk. And I won't talk about what colostrum is. That's just the pre-milk. Similarly, we have all the different minerals and vitamins. In breast milk, we're also very important different types of hormones, growth factors, and there's a good sized microbiome in human breast milk as well. And the last one there is microRNAs, and we'll talk about those as well. So this is just a small sort of snapshot of what's in milk or human milk. If we compare that with bovine milk, we have to go back and think about what are we using this milk for? Humans, obviously babies, bovines, calves. Is there any difference between a calf and a baby? Yes, of course there is. A calf, when it's born, is up on its feet within minutes. Babies, they take about a year or more. Calves are, I won't say they're self-sufficient, but they're more capable, they're more developed when they first come out than babies. And that might be one reason why we have more growth factors, etc., in human milk compared with cow's milk. It could also be why the lipid profile is slightly different, why the protein profile is different. If we look at the table on the right-hand side there, now, can you guys see my arrow, or is that just me?
Yes, we can see your arrow.
Okay, that's good. I won't flash it round all over the place or Jenny will tell me off. But if we look at a few things like protein, humans, 1.2% protein, cows, about 3 times that, 2 to 3 times that. So that's a big difference. If we look at the individual proteins, caseins, there's very few caseins in human milk, a lot more in cow's milk. So we have to ask, why is there casein in cow's milk but not human milk? If we look at whey protein, they're roughly the same. That's the concentration of the protein, not the individual proteins, and we'll talk about that. Fat's roughly the same. Carbohydrate, there's more carbohydrate in human milk than cow's milk, and we'll talk about that as well. And ash, well, it's less than 1%, so it's roughly similar. So you can see just at a very large scale type looking at it, yes, there are differences. And the big thing that we've been asking over the last 40 years while I've been looking at infant formula is, why are there differences? What are those differences? And does it matter? So here's the definition of milk, and some of you who may have seen some of my other seminars will have seen this one before. It's just bog standard definition. This is mainly for milk for commercials, so it has to come from cows, goats, sheep, water buffalo, etc. Notice there's no mention here of plants, and I'm not apologizing for the fact that there'll be nothing. I won't be talking about plants at all today. If we look at milk again, we can look at it in the large scale. And this is the same or very similar to what we had before. Just showing you most of milk is made up of water, 87% roughly water. It's that other 13% that is the very important parts. I've asked this question before, and I'll ask again, how many components in milk? And I ask this of my students, and they all say, oh, about 100, 10, whatever. And if I was doing a discussion with you now, I'd ask you, actually, you could do that, put it in the chat now, and we'll look at the answers at the end of how many components you think are in milk. Okay? I'll give you 2 seconds. 1, 2. Right, you've done that. Let's go on. The answer is about 10 to the 5, or up to 10 to the 5. And that was way back in 1988. That was before we even knew what was in milk. So 10 to the 5 is about up to 100,000. I'd say that might be a bit high, but it's doable. It's somewhere in there. So if we think about milk, we have to ask which ones are important. We've got the proteins and we've got enzymes. Anyone who has dealt with infant formula at all will have heard of lactoferrin, and we'll talk about that later. There's also things like MFGM, and I hate acronyms, so I apologize for that. It's milk fat globular membrane. That is the membrane that surrounds the fat globules in milk. And inside that membrane, we have different components such as proteins and different types of lipids. They're all there for a purpose, okay? And then we have proteins that can be broken down, and they're called hydrolysates. When we break them down, we form peptides, and these can have bioactivity. And what we're doing here is mimicking what happens in the gut and in the stomach of the either baby or the human. And of course, we have lipids, we have oligosaccharides, and then vitamins in the smaller molecules. So there's lots of different bits in milk. As well as thinking about the scientific side of infant formula, we have to think about the economic side, and it's huge. If you look there, US dollars, 70-odd billion 2 years ago, going up to 82 billion in 5 years. Well, it's only 3 years' time now. That's huge. There's a lot of money. US and China, the biggest markets. India is now got the largest population of any country in the world, and that demand for infant formula is growing very quickly. China, they're starting to stagnate a wee bit. Their birth rates are going down. So their demand for infant formula isn't as high, but the people that want infant formula are driven by value and premiumization. And by that, I mean, what can you put in there that demands a premium? Now, another interesting thing about infant formula is safety. And we always have to think about safety because of some bug problems in 1 or 2 of the plants over in the US. Over the last few months, or about 6 months probably, they've had a huge shortage of infant formula. And this is just showing you this one down on the bottom right. We don't need to talk about that. Okay. I had to do the disclaimer right at the start. What do those people out there say is good about breast milk that's not in infant formula? I got this from a website, and I don't completely agree with it. But this is the sort of information that's out there. Breast milk contains at least 34 important ingredients not found in infant formula. Well, this is, I'd say it's BS, to be fair. But what infant formula people are doing are adding back some of these components if they're not there in the same levels in cow's milk as they are in breast milk. Okay? So that's quite important. As I mentioned, I'm getting a bit long in the tooth now. These are just some articles I found from years and years ago. What did they do back then? They basically had dried skimmed milk or full-fat milk. They added a bit of iron to it, and sometimes they added a bit of sugar. Not much, really. It seemed to work. Why bother? That's good. Go for it. We seem to have become a bit more sophisticated. Here's a beautiful ad I saw. Look at those eyes on that little baby, eh? Obviously likes what she's looking at. So 40 years ago, what happened 40 years ago? In the 80s, in the US, and this was passed on to the whole world, the World Health Assembly looked at all the marketing that was going on with breast milk substitutes, and they made a codex code that everyone theoretically had to adopt, and made sure all their companies fitted in with this code. This is because there were some pretty shonky practices going on back then with some of the different formulas that were out there. When I came into the industry, the big thing, if we went back to the first or second slide, was the amount of whey and the amount of casein in cow's milk versus human milk. And there was very little casein in human milk. So what they did was say, right, we have to add whey protein, to get that ratio of casein to whey the same as in human milk. They did that way back in the 60s, but it really took a long time to come through. At that stage, they were also adding specialized fats, some vitamins and some minerals in what's called premixes that were added to the formula. Really fascinating history of infant formula, but I won't go through it. We could spend a whole hour just talking about that. Here's just to give you an idea of some of the things they were doing. The whey protein ratio came in about 1962 here. Iron came in back in early or late 50s. What you'll see if we come up further here, 71, we started thinking, babies may not be able to utilize milk protein from cows. We'll hydrolyze it. That means we're going to chop it up to make it easier for the baby to digest. 84, they added taurine, and that was to help fat absorption. And then they start getting into some of these more specialized products in the 90s and in the thousands. And we'll talk about some of those as well. Right. Let's talk about milk, breast milk, cow's milk. If we look here, we're going to start with the biggest component, which is lactose. What's the difference between lactose in humans and cows? And although I could talk about sheep and goat infant formula, I'll really just talk about cows, okay? What is lactose? Lactose is an energy supply. A lot of people say, oh, my baby's lactose intolerant. And yes, there are quite a few people that are lactose intolerant. Most babies are not lactose intolerant. There's very few that are lactose intolerant. And again, I could talk for an hour on this. Babies, we all have a gene in us that produces the enzyme that chops up lactose. About 10,000 years ago, that gene was turned off after the baby stopped breastfeeding. And so most humans, 99% of humans, were lactose intolerant after they'd stopped breastfeeding, okay? There's very few people, very few babies where that didn't have that gene to start off with. As we develop the propensity to start drinking milk, that gene didn't get turned off as quickly. And that's a big difference with lactose intolerance. So if anyone says, my baby's lactose intolerant, okay. Often you don't want to fight with a mother, but that's what it is. The next highest compound in breast milk, and therefore in infant formula, is fats. There are some differences. And there's a table down the bottom there just to show that some of the omega-3s and omega-6s, their concentration, especially omega-6, the concentration in cow's milk is a lot lower. So omega-3s are added. What is omega-3? The one that we usually think about is, where are we? Conjugated linoleic acid. And most of you would have heard of omega-3 and omega-6 and the pills that you can take, the tablets you can take to give you lots more higher levels of those. So those fatty acids are ubiquitous. That's fine. But we can interchange them between human and cow's milk, and it's not a problem. So that's a simple one. The third highest compound in breast milk, and if we just come back here, what we'll see here, in human milk, we have 70 grams per litre lactose. That should be sugars, total sugars, because it's lactose plus oligosaccharides, human oligosaccharides. So if we look at oligosaccharides, as the name suggests, they're made up of more than one sugar added together. In humans, we've identified over 200 of them. In cows, well, I think we're only up to around 100 at the moment. Cow's milk has a lot lower concentration of oligosaccharides to human milk, breast milk. The oligosaccharides in human milk are also what's called fucosylated and sialylated, and that just relates to the sugars and how the sugars have been converted by having a silolactose on it, or sialyl group on it, sorry. So this is important. And what I always ask is, okay, if we have over 200 oligosaccharides, are they all important? Are some more important than others? And this is a really interesting question, because the way I look at it, why would you have any in there that don't do anything? We've got evolution, so we're not going to have things that redundant sugars in there just for the sake of it. Why are they there? I've got a whole list, and you can have a look at these at your leisure. The main things for oligosaccharides is to help the gut bacteria. So what they do is they're sugars. Bacteria feed on sugars. They have specific sugars that help the beneficial bacteria grow and retard the growth of pathogenic bacteria. So brilliant. It's a really good mechanism to make sure that as the baby evolves, it has the right gut microflora. And that is very important because, as we know now with Crohn's disease and a lot of other celiac type diseases, I'll call them symptoms, not diseases. We have very specific requirements for our gut microbacteria, okay? And that comes from day one. So we have to make sure we give our babies the best chance we can of developing the right diversity of microbes in the gut. Here are just some of the oligosaccharides that have been identified in human milk, for example. You can see that quite a diverse array, and they're made up of a whole lot of different subunits: glucose, galactose, acetylglucosamine, fucose, which I mentioned before with fucosylation. We can also make oligosaccharides, and oligosaccharides that we make that prove to be beneficial for the gut health and the gut bacteria are called prebiotics, and I'll talk about this later. And prebiotics we have include things like GOS and FOS down here. What you'll see with GOS and FOS is that they don't have the diversity of human oligosaccharides, the ones here. They're very simple structures. This is a paper that just came out last week, I think it was. Infant formula with, these are two human oligosaccharides, positively modulates the infant gut microbiome. And they've done this using human intestinal microbial ecosystem model. So this works in humans. I think that's very important to have that sort of proof nowadays. How can we produce human oligosaccharides, milk oligosaccharides? Breast milk, obviously. But the good thing is we can also produce some of them chemically, some of them using enzymes, and some of them using microbial fermentation. How many have we produced so far? If we look at down on the left, you'll see we've got 2 fucose lactose, 3 and 6 siolactose, LNTs, and difals, difucose lactose. Those are the main ones that we've looked at so far. Those are the ones that have been produced synthetically and been added to infant formulas. And you can see the different products that they've been added to. They can be made in a number of different ways, as I mentioned. And Taiwan has just allowed the use of 2 fucose lactose that's been produced by microbial fermentation here to be used in medical infant foods. So that's really good. This has really only happened in the last 10 or 15 years at the most. This is brand new science, but it's adding so much to infant formula. Right, let's think about protein. So that's we've done lactose, we've done fats, we've done oligosaccharides, now the proteins. Everyone thinks protein is really important. And is it? Well, what happens to a protein in the gut? It gets broken down into peptides and amino acids, and these are absorbed in the intestines. I find this really fascinating because should we be worried or not? And I don't know the answer. If we look at some of the different proteins, alpha-lactalbumin, for example, has twice the concentration in breast milk, whereas breast milk for these two caseins, it doesn't have any at all. It's bizarre. There's none there at all. So obviously babies don't need it, whereas cows do. There's high levels of alpha casein. Similarly with beta casein and kappa casein, very small amounts compared with cow's milk. So babies, they just don't need those caseins at all. Immunoglobulins, they're about the same, but we'll talk about that a bit later. Lactoferrin, 5 times as much lactoferrin in breast milk. Beta-lactoglobulin, which is one of the whey proteins, it's a main whey protein. Again, breast has none. Breast milk. Why? So we can look at cow's milk and the proteins in cow's milk and say, well, look, most of them we don't need, but there are some that we need more of. So, this is really interesting stuff. There's also a whole lot of smaller enzymes and proteins there in smaller amounts that we just don't really know about. So I think we have to do more research on, do we really need caseins there at all? And what whey proteins do we really need? So how do we make the protein more like breast milk? We've talked about the ratio of casein to whey, the individual proteins. There's some people coming out now with ingredients that are high in alpha-lactalbumin. Remember, that was double the concentration in babies in human milk. So if we look at this table here of some of these, we have vastly different amounts in human milk compared with bovine milk. And we have to really think about that. If we think they're important, we have to do something about it. If we think about immunoglobulins, for example, in human milk, they're mainly IgA. And this one here, a standard immunoglobulin is IgG up the top here, this yellow one. And that looks like a Y. Okay? In human milk, instead of that, we have IgA, which has got 2 Y's connected together at the bottom. What's the difference between them? What are these immunoglobulins? Another name for immunoglobulin is antibody. What are these antibodies against? What are they raised against? Is that more important than having IgG or IgA? We don't know. There's all these things we still don't know, but it's really fascinating. It'll keep me in a job until I'm at least 200, I suppose. Lactoferrin, I mentioned there's 5 times as much lactoferrin in human milk. And we've been adding lactoferrin back to our infant formula for years and years. And this is one brilliant success story. Lactoferrin has so many different activities: antibacterial, antiviral, antifungal, bone, wound, cancer, and immune function as well. So it's a very important. And I think the lactoferrin is there in higher numbers in human milk because our babies are so pathetic when they come out compared with calves. They need all the help they can get. So it's really brilliant that we're adding lactoferrin. Vitamins, there are differences in vitamins. We know that. I've just put a red ring around all the different vitamins that we add back to infant formula. That covers almost the whole range of vitamins. Some of them we think breast milk is just too low anyhow. So in formula, we add more than we need to. Again, we could ask, is that good or bad? We have to trust the doctors for that one. And the vitamins are made up of either water-soluble or fat-soluble vitamins, and they're normally added as a premix. Similarly with minerals, I mentioned earlier on that we've always added iron. We want the babies to have lots of iron. Do they need lots of iron? You can see how low it is here. And it's similar concentration to full-fat milk. And if we come back to the red circle over here, you can see we're adding sulfates, we're adding potassium, magnesium, etc., etc. So we're adding lots of other ions as well, minerals as well, that we think the baby needs. Whoops, sorry. Okay, so that leads me on to, we know all the different components in human milk and cow's milk. We can mimic a lot of them to a certain extent, but not fully. As I mentioned, we have different types of infant formula. We can have a bog standard infant formula that offers, just a balance of fat, protein, lactose, minerals, vitamins, etc. But we are now going for these premium formulas, gold infant formulas they're normally called. They're balanced, they contain everything a baby needs, but they also have other ingredients that may, and notice the big may, provide additional benefits. Let's talk about some of those. Prebiotics. We talked about prebiotics, what they're there for. They're there to help the bacteria in our gut. The oligosaccharides, that means they're made up of lots of sugars. They've been found to be safe to add to infant formula because they're there obviously in human infant formula, in human milk. They're not necessarily the same structures as found in breast milk. But trials have shown that if we have infant formula that's had prebiotics added to it, the gut bacteria are more similar to breastfed babies than infant formula that doesn't have prebiotics. And the poos, and we have to always talk about poos with babies, are very similar to breastfed babies as well. Immune function, we're not so sure about. So there are some ways we can say, yes, prebiotics are good. As I mentioned, what prebiotics? Here's just some more examples. Are they all the same as human milk oligosaccharides? I say no. Some people say it doesn't matter. There's been lots of studies, and most people, if you say it's a prebiotic, they think, oh, cool, brilliant, lovely. I'll be careful about that. Next one is probiotics. And we all know about probiotics. We have probiotics everywhere. These are bacteria that are found are really good for you. They help your gut, etc., etc. Probiotics, when we have to be careful about the definition, are live bacteria that are added to infant formula. This is just one from Morinaga on the right, Bifidobacterium longum. Most companies have their own, they're normally bifidobacteria that they think are brilliant, and they'll add to infant formula if they can. Improve gut health, improve immunity, protect against allergies. Current research, not conclusive. It depends on the type of bacteria and how much you add. But a lot of people swear by them. And I think the more evidence is going to come in, similar to some of the evidence that we've seen before. The next one is an interesting one, is probiotics. What are probiotics? Postbiotics. Postbiotics are slightly different, okay? Postbiotics are the benefits you get from a probiotic that has been grown up and then killed off. So what we think is that the probiotics, when they grow up, they produce molecules that are really good for you. And these are called postbiotics. And there's been some studies to show that, yes, you can add postbiotics, probiotics, prebiotics, all sorts of things, and babies like them, and they're good for them. These are very new, the postbiotics. Prebiotics, as I mentioned, haven't been around that long either. Now, another one is nucleotides. And what are nucleotides? We should have all heard about nucleotides. Building blocks of DNA, okay? They're in breast milk. They're there to help promote growth, gut function, immune function, sleep, all these standard things. How many nucleotides are there? 4 different types, if they're the building blocks of DNA. Can we add them to infant formula? Yes. Safe to add, and we've been adding them for a while. Again, trying to mimic the levels that they are in breast milk. And they've had studies to show, yes, it does enhance growth, immune function. Sometimes better than vaccines. And they think they may also have a prebiotic effect. So there's something else we can add to our infant formula. What happens if we have allergies? Some babies have allergies. Most of the allergies are against the milk protein, but it's not that rare. So not that common, sorry. I saw a figure up to 2%, but I'm not sure if it's even that high. We can get around this. And a lot of people have trouble distinguishing between an allergy and an intolerance, okay? You have to be careful with allergies. They can lead to anaphylaxis if you're really nasty. And some people say, oh, well, we'll just use goat milk or soy instead. No, that doesn't always work. There's been some studies I've seen that say camel milk is good, but where the hell are you going to find camel's milk? So good luck with that one. What you can do is hydrolyze or break down those proteins into short peptides, amino acids, and that's a good protective measure. And they'll often do that if a family has got a history of milk protein allergy. They'll suggest they have partially hydrolyzed or extensively hydrolyzed. Hydrolyzed, that just means how much you chop it up, okay? The more you chop it up, the less likelihood you're going to have any sort of allergic response. And then if you chop it up completely to the individual amino acids, you're not going to have any response at all. Right, let's rattle through some of these favorites that we've got out there now. We all know about A2. You guys have lots of A2 over in Australia. A2 is a type of casein, and we could argue, well, human milk has bugger all casein anyhow. So if we got rid of most of the casein, we wouldn't have to worry about whether it was A1 or A2. But that's a different story. Organic, yeah, I had a PhD student looking at organic milk versus conventional milk. Bugger all difference, not really much difference at all. But some people, here's one, Ocean Road, that's organic and A2. So no wonder those cows are happy. They're getting 2 premiums. Well, I assume they're getting premiums. Lactose free. How can you remove lactose? It's the main component in cow's milk. It's also the main component in human milk. You can remove it, but this is the ingredient list. You've got glucose, vegetable oils, calcium caseinate, more sugar, as well as all your fats, minerals, vitamins, etc. Sure, I'm sure there's a need for it, but yeah, I'm not overly convinced yet. Go and see your GP if you have that sort of problem. There's also colic and constipation. Again, what is colic and constipation? In this case, we use hydrolyzed milk proteins, mainly the whey proteins. Again, if you think it does good for the babies, go for it. And if you're making infant formula, it's another way into the market. I'll leave it at that. So what's going to happen in the last 5 minutes? I'll just talk about what's going to happen in the future. The big thing is going to be the infant gut. Okay, there's no 2 ways about that as far as I can see. One thing we haven't really talked that much about is the milk fat globulin membrane, and I think that's going to become more important with the phospholipids, the gangliosides, etc., the glycoproteins, glycosphingolipids that come from the milk fat globulin membrane. I think they're going to be very important in future. There's also some other ones I've talked about, microRNA. We know there's microRNA in there. There's also microRNA in cow's milk. Is it the same? What does it do? How important is it? We're just starting to understand some of these things, and I don't have the answers for that one. Down the bottom, you can see we've got symbiotics and postbiotics. I think they're going to become more prevalent. Symbiotics is a combination of pre and probiotics. They really, for me, we really need to have a good story for them, though. Okay. Or we're just adding more buzzwords. But if at the same time we're trying to get a premium. Here's your milk fat globulin membrane. Helps boost cognitive development. Phospholipids, gangliosides, as I said. These are some of the dubious marketing. Could boost IQ and immunity. Could, notice the could. These are some of the things, statements, etc., that are getting on the goat of some of the regulators. So we have to be careful about that. But I can see a need for milk fat globulin membrane down the line as well, similar to phospholipids. I gave a talk 6 months, a year ago on artificial milk, and there's also a couple of startups that are using human breast cells to produce milk. To me, that's brilliant. If you've got a young mum or an older mum that can't produce milk, if you can get cells, her breast cells, and make them produce milk, I think that's a great way to go. It's a substitute for breast milk, but it's going to be very expensive. It's going to be technically challenging. And do we really need to go that far? We've also using precision fermentation or genetic engineering, whatever you want to call it, to produce a lot of these human milk oligosaccharides. So that, yeah, I'm not ruling it out. This is one out from North Carolina, using mammalian cells to secrete milk. I think it's brilliant. It's going to be bloody expensive though. So the good thing about it, it matches the profile of breast milk. We don't have to worry about adding this, adding that, adding the other. So that would be good. Certainly it got the advantages of no cows, etc. So where have we come in 40 years? We've come from this basically dried milk powder that's got got iron added to it, and that's about it, to very specialized powders. More sophisticated, they're targeted. What we have to think about now is the value of them, and I put cheaper question mark and safer question mark. So we're always up against the safety, and we don't want to price people out of the market either. We'll end out with the old and in with the new. And with that, I will leave it and look forward to answering some questions.
Okay, thanks very much, Don. If people can type in their questions now, that would be really good. Don, a question that I've got just while we're waiting for a few to be typed in is if parents start feeding their children lactose-free formula, is that likely to create more allergies to lactose or intolerances to lactose in the future?
I would say no, because everyone's got that gene. It's whether it's turned off or on.
Mm.
So at the moment, every baby, it's turned on, apart from very few. And then it's turned off, as I mentioned, after lactation ends. And it's taken years and years of evolution to achieve that. So it took something like 2,000 years. So I'm saying no, because in my pessimistic, optimistic state, I think humans aren't going to be around in 2,000 years because of what we're doing to the earth. How's that for a really nasty answer?
That's good.
Any other questions out there? Matthew thought there was 4 components in milk. Well, okay. My brother had watered down evaporated milk. That was 50 years ago. And your brother's still alive and kicking. What's the bet, Sharon? There's a lot to be said for moderation in all things. We can get fancier and fancier. And I've always asked, do we need to? What are we achieving? or the other way of looking at it is, what are we doing now that in 20 years' time, will they think, why did we ever add that? Why didn't we do this? For me, maybe growth factors are going to be important in the future as well. Shane asks, thanks, Don. Down the line, do you think the regulations will move to make formulas more like human milk, i.e. no beta lac and increased alpha lac? I think the regulators will be there's not enough evidence to say that beta lac is harmful. So they won't worry about it, because you've got the economics versus the science. And unless it's proven, and A2 milk has this problem at the moment, there's still not a lot of evidence that A2 versus A1 causes huge amounts of problem. And so nothing's going to change. So I hate to say it, but no, I don't think much will happen. Excuse me, much will happen. Of the people out there, also, what are your thoughts on plant-based formulas? The big thing about plant-based formulas are the proteins. And again, the oligosaccharides are completely different. The proteins are completely different. The fats are completely different. So you're going to have to add so many components to them. It's like artificial milk. Some of the cultured milk products they're making now, they're saying, we are producing ice cream without cow. And what they've done is made beta lac, added all these other components to it that have nothing to do with dairy, and then they call it milk ice cream, and it's got nothing to do with milk ice cream as far as I can see. So plant-based formulas, if you have so many allergies, etc., you have to give your baby something. Yeah, I don't see any great advantages. Of the people out there, how many of you produce infant formula now, and where do you think it's going to go?
If anyone would like to unmute and talk, you're welcome.
Don, Shane here.
Hi, Shane.
Listen, thank you very much for that. Very informative and always interesting to get your thoughts. Yeah, we make infant formulas all the way from pregnant mothers straight through to kids' milks as well.
Sure.
But they're all dairy based. We don't any plant based formulas at the moment. But with the way the world is changing, it's keen to get your thoughts in terms of, marketing versus the science behind things like plant-based and also precision fermentation and where the future might go with that as well. So, yeah.
With plant-based, I can see more hybrid products to start off with. So you still contain some milk but add some plant proteins or something to it. But the whole digestion is going to be different. The sugars are going to be different. Everything's different. But there have been plant-based formulas out there for years and years. You're up against the economics and the whole idea that as people go from a developing to a developed country, the amount of protein they eat increases, and so the demand that they have for meat and the demand they have for dairy also increases. So for all the negative publicity against meat and dairy, they're still growing. We can't keep up. So if you're making a milk infant formula now, I don't think you're ever going to run out, to be fair.
Perfect. Thanks, Don.
Okay, thank you very much, Don. Our time's actually up now, so I want to thank you very much for the time and effort you've put into today's presentation. If anyone has further questions, Don has included his email address on the first page of the PDF that I have sent you. So with that, sorry, I didn't have my video on. With that, we'll say cheerio to everybody, and looking forward to seeing you again next week, which is our free webinar, and we've got dairy situation and outlook and update on the Southeast Asian markets. Okay, thank you, Don.
Not a problem.